All right, on to the fun stuff. The phase inverter, as you will have seen from the previous video, measures 238.6K on that grid leak, bias leak, 236.4K there. Those are fine. They're matched well enough. This 100K measures, I said this 100K measures, come on meter, 127.5K, so that's drifted up quite a bit, almost 30%. And this one, which is supposed to be 82K, measures 163K, so that one has drifted up 100%. So it's just about twice the value it's supposed to be. So of these resistors, these two can stay, these two must go. Now look at the nice, pretty, shiny, rounded, domed solder joints from the factory. And here, there's not quite as pretty on these as there is on here. When I am done with this, I want these to look as much like these as possible, and I don't want a whole bunch of junk on the board. So let's see how I do. This is going to be a little bit tricky with the camera here, so I'm actually going to move it to the other side so it's out of my way. It won't be quite as good a view as this, but it should be good enough, and I'll show the after. Freshly tinned iron. A little extra solder added to help this joint loosen up. And I'm just going to very carefully lift this wire out. And see if there's any. All right, good. That resistor lifts right out. This capacitor lifts right out. That'll just get carefully tilted up in the air. Same here. You can see some bubbling coming out of this resistor. The resistors absorb stuff from the air, and that moisture content bubbles out when they get heated like this, and that's also one of the reasons they drift. So disconnect the B+ connection, move it to the side. These resistors will be returned with the amp, though they would not sound very good. All right, I want to get the old solder out of these eyelets, because if I add fresh solder to it, then you get too much solder and it pools up beneath the board. And it's very common for solder blobs in these old amps to pool up and break free and drift off and cause random shorts. Like I mentioned, this solder sucker is on its way out, so this won't be as quick as I might like. But it will do the job. The best ones are the great big solder bolts, but their tips wear out so damn fast. And I usually order a whole bunch of tips when I get one, and I have run out of those. So anyway, this would normally be a one pump kind of thing, and all the solder's out. That's the worst of it. Let me use this braid to get the rest up. And I want to make sure that the eyelets are clean with no excess flux, though there's not a lot on this board. There's a little bit here. Make sure that the eyelets themselves are nice and clean. Just a little bit of flux here on this bias voltage eyelet. Get that off while I'm in the area. And I like to Make sure there's no corrosion on the eyelet itself. And let me find my paper towels. The isopropyl in that area. Get all that flux off. And I'll make sure the board is clean at the same time. So let me get some fresh paper towel and see what color it comes up at this point. This board is so exceptionally clean, it should be a non-issue. Some of them, as you will have seen from my previous videos, have got dirt and corrosion and all kinds of yuck and take a lot of work. This one should be a piece of cake. All right, that's very good and clean. Not much came up there. Now, while there's some moisture on that board, I'm going to heat up each one of these eyelets and drive the moisture out of the board surrounding it. You can see it expand in a little ring. And that has evaporated most of the alcohol remaining on the board. Which just leaves us with a very nice clean board. Practically the same as it was at the factory before any components were installed. So I need a new 100K here and an 82K here. And COVID has been a little bit problematic for a lot of us in that parts that used to be readily available. Let me start that again. So we need a new 100K here and an 82K here. Normally, these would both be 5% gold band tolerance resistors. COVID has made a bit of a problem getting parts this year, and things which used to be easily available are now out of stock for weird periods of time. So what I have on hand here are two very high quality current production half-watt carbon composite resistors, but I've got the 10% on the 100K, and I've got the 5% gold band on the 82K. So they're not going to match precisely the color code in terms of the silver versus gold band that would have been on the original, but they will be the correct values. Now, this 100K is measuring 92K. I think I'll find a different 100K. It's a little closer to the desired spec. This 82K measures 81.2, so that's good. Let me find a 100K which actually is closer to 100K. 92 is at the low end of it, and that proportion between the 100K and 82K is pretty important. You don't want to have something that's too far off from the design spec, or if they are off, you want them to be pretty much the same ratio to each other. So I'm going through, I've got a reel of 50 100K resistors here. I'm just going to find the one that makes me happy. And there's a wide range from about 92K to 110K within this reel. All right, this 100K is 99.6K. That is close enough for rock and roll, certainly. So I could eyeball this, but I kind of like to use one of these to get them exactly the same. And I like to use calipers to see if there's any variation. Usually this is 0.85 an inch from the factory. Let's see if this board is on both of them. I'm going to do this without hitting the... All right, so that's a little bit big there. Let's try 0.8. .8 looks very good there. 0.8 is very good there. So I'm going to bend each resistor to 0.8 inches, which will get them very neat. Neatness counts. Get that centered in there roughly. There's one bent. Two bent. Now, in theory, you would want these leads to go under the eyelet and then bend underneath. And if I were building this board from scratch, that's what I would do. But if you saw earlier in the same video, the originals were not doing that either. And while on some things, it's crucial to have that mechanical support, it tends to be things which have some weight or some mass. And in the case of this amp, they're almost always the same thing, or vibration or any strain on them. Now, this one needs a little bit more finessing beyond what the vendor did. A slight bit more. So there we go. It does not need to be all the way bent underneath the board like it would on a higher mass thing. But I like to get in there and kind of bend the lead around the edge using a small screwdriver or a dental pick. So there is a little bit of tension on it, even if it's not the full amount you might get from a partial wrap underneath the board. Let me give myself that same bit of excess over here. I think I just used the wrong end of the 0.8 opening. Should use the slightly wider end. So both resistors are in place. Notice that the tolerance band, gold and silver, is towards the front of the amp, which is how all the other Fender resistors are. And I'll get in here and do that little partial bend as well. Another reason it's nice to get the old solder out. All right, and I've got this old B+ wire here, which was tucked under a little bit. So I'm going to kind of pre-bend that again. See if I can get that to tuck in there for a little bit of a support there. And there's a little bit of stray cotton I want to get out of the way. Now I'm going to do something which is a little bit odd. The original Fender joints, as you can see, have all these big pools of solder. That's because they were actually soldered with the board upside down. They were soldered from the other side and the excess pooled up. And they used a very large, very hot iron with very thick diameter solder. And that's what we're used to from Fenders. And it's pretty, and it's just how they look. That's actually not what mil-spec wiring indicates. Mil-spec would say a joint more like this, where the eyelets and the leads all are connected to solder, and the solder is filling the gap, but it just has what they call a fillet of solder. It doesn't have a big dome there. And that is just as strong mechanically as this. It's better in terms of service, and you're not going to have excess pooling. However, for Fender joints, I try to make it look like the old ones because it makes people happy. Now, I'm not going to show you how I do that because I have to have some secrets, but I'll show you an after. And it looks pretty darn close, even though I'm doing it from the top, and I'm not using a huge iron, and I'm not using a huge spool of solder, or a spool full of huge solder. So let me do a little prep work here on my end. I'll do that up. I'll show you the after. Then I've got to repeat it on these, and then I'll be doing it again later when we do all the electrolytic capacitors. So take a last look at this before. And there's the after. A nice pretty dome that doesn't look exactly like any of the originals, but none of the originals look exactly like each other. It would fool all but the most experienced techs. So now let me put these capacitors back and the wire leads back and redo the solder joints there the same way. And then I'll move the camera so you see the after from the same angle that you saw the before at the beginning of this. Okay, again, we've got the actual mil-spec solder that's not pulled up and pretty like the originals, but it is actual mil spec. Every component in there having a mechanical connection of some sort or some strength to the eyelet before solder is applied. And that's my wife sneezing outside. And now I will do the cosmetic solder joint and show the after. Phase inverter redone there. New plate resistors, the correct value. It should sound a lot better because this one was about to fail. And cosmetically domed solder joints, just like the original. Now, I'll have to do the same thing on all these electrolytic bypass caps on this board. And I'll show all that stuff once all the new parts arrive. But it feels good to have done this and know that you'd have to be a very experienced tech to look at this board and even see that something had been done here.